Hi, my name is Nick Borson, and in this video I'm going to talk about how to query a database from PowerShell. So to start with, I'm going to show you a sample Microsoft Access database, walk you through that, kind of show you what tables it has, how it's organized and structured, and explain some basic database concepts. Next, I'll show a simple PowerShell script that queries a single table from that database. And then we'll build on that to show a little bit more complex queries that involve multiple tables, joining information from multiple tables. And considering a hypothetical use case where, for example, you might want to have a set of orders and you want to generate a billing statement for a customer based on what they've ordered. Finally, building on that further, we'll write information about orders or about the query results to an XML file, and also to an HTML file. XML would just be, a simple file representing the data, so you could use it as input to something else. And the HTML would be the same data, but in a formatted form that you might send to a customer or something as a billing statement. So let's take a look at our database that I'm going to use for demonstration purposes. This is the application I have open here is Microsoft Access, which is part of the Microsoft Office suite. Access is a user-friendly database that's suitable for small businesses and so on. What I've done in order to give us some data to work with is I created a new database using a template that comes with Microsoft Access. And this is the Northwind Starter Edition template. And this is a database that Access provides as kind of an example to demonstrate its main features. And so for our purposes, this is useful because you can create the same database and follow along if you like. This database sort of comes pre-populated with some data that we can use for our queries. And it's a database that is designed to represent something that might be used by a fictitious trading company, as it says here, whose customers are independent grocery stores, and so it has information about their customers and their orders and so on. So in the examples, I'm going to walk through how we might bill customers based on what orders they have that are shipped and ready to be paid. So I'm going to close out of this because I'm just going to look at the tables. So the database you can define queries and all kinds of things. Access has a lot of features, which I don't necessarily know a lot about because I don't work with databases all that much, to be honest. But I can at least show you what the tables are in this database. And the first table we're going to query is the orders table. So I'm going to open this orders table, and you can see why it's called a table because it has rows and columns. So the columns correspond to the different fields that have been defined for that table. Each table has when you create a table, you define what fields it has and what types each of those fields has. So it's not a free-for-all thing. You have to actually define the table up front. So each record, each row in the order table has to have an order ID, a salesperson, a customer, order date, and so on. Now we can see that some of these fields are simply numbers. For example, if I scroll to the right here, let's see. Oh, okay. For example, the third column here, we have customer. Well, the customer is just 7 or 1 or 2. So what does that mean? Well, in order to understand that, we have to look at this is what's called a foreign key. So for example, here, the first column is the primary key for the orders table. So each order has a unique number that identifies that order. So order ID 1 uniquely identifies this row of the table, and likewise 4, 5, 8, 9. They don't have to be sequential. It's just made that those numbers are assigned automatically every time you add a record to the table, and then they never change. So it's a stable identifier for that record. Now, one table can then refer to elements in another table by their key. So customer here is referring to a record in the customers table. So if I open the customers table, we see that record 7 there is Tailwind Traders, for example. So the customer ID is referred to, the customer ID is the primary key of the customers table, and in the orders table, the customers column refers to a customer by its customer ID. Okay, so that's kind of explaining a little bit how tables are related to each other. That's when people talk about a relational database. Those relations are defined by having tables refer to each other using their different keys, and that allows data from different tables to be combined together. Okay, so let's take a little closer look at how our first example here, we're going to query this orders table, and we're going to pull out all the orders that are ready for us to send a bill for. So we're going to look for orders that are in their shipped state. We see that some of these orders have a shipped date and some do not. But the real thing that we're interested in here is the status ID. So the status ID tells us what orders are in what state. And those states are defined, again, by another table. We can see that there's an order status table. If we open that up, we see that an order can be new, invoice, shipped, paid, or closed. So now I don't really know in detail how this database is meant to be used, but I'm speculating that an order in the shipped state is one for which we are ready to send a bill to the customer. So we're going to look for orders that have status ID 4 because that status ID corresponds to the shipped state. So if we go back to our orders table, we can see that some of these orders have status ID 4, for example, this one. Okay, so so as a first step on our journey here, let's go ahead and create a script that will query the orders table in this database and pull out all the orders that have status ID 4. Okay, here's our first script. So in this script, we're going to open our database and we're going to query the orders table, and we'll simply output information about each of the orders that is in the state that we're looking for, the shipped state. So let's take a look at this step-by-step here. So let's skip over these first two lines for now. Now here is the file path of the database file I'm going to open. So this is just the path of the Access database I created. The database is in the same directory as my PowerShell script, so I just used the join path command to combine the file path of the directory path of the where the script resides with the file name, and this will give us the full path of the database file. So that's what's assigned to this db path variable. Then we create a connection object. So this is using a technology called ADO or ADODB, active data objects is what ADO stands for. This is a sort of extensible open technology that allows multiple database providers to all be accessed in a uniform way, as long as they implement these interfaces that ADO defines. So this is all based on COM, Component Object Model, which is kind of a precursor to .NET, and it's still used for a lot of things. So we use the new object command to create this connection object, and we're creating a COM object, so we use the COM object switch, and this is the name of the COM class, ADODB.connection, that we're creating. So we get this connection object. Once we have our ADO connection object, then we call its open method, and we specify the connection string, and the string includes the provider name. Like I said, ADO has this provider model where different kinds of databases can implement their own providers. So there's kind of this magic string, and as part of that magic string, we have our file path of our database. So we've opened our connection, and we can then use that connection to query different things. Now, in this script, I've written a function called getShippedOrders, and for each record in the orders table, for each matching record in the orders table, it returns an instance of this class. So this class so I've defined a class here in PowerShell using the class keyword, and I called it shippedOrder because we're using it to retrieve information about orders that have shipped. And for each of those, we're just among all the many fields that we saw in the orders table when we looked at our database, we're just interested in 3: the order ID, which is the unique identifier or primary key of that order, customer ID, which is the foreign key that refers to a record in the customers table, and then the shipped date for that order. So each instance of shipped order will have these 3 fields in it. So here's our function that's going to get the orders. So we start by defining a query string. So this is a SQL query. SQL is SQL, stands for Structured Query Language. And this is a language that's widely used to access databases. And we begin with the select keyword, which means we're going to select data from our database. And specifically, we're specifying which fields or which fields, which database columns we're including in our results. So we're including just these 3 fields instead of all the fields from the orders table. We're just including the order ID, the customer ID, and the shipped date fields. We're getting those fields from the orders table, and we use the where clause to say that we only want to include results where this condition is true, namely where the status ID field of the record is equal to 4, which, as we saw looking at the table, 4 is the ID of the status that means the order has shipped. So status ID equals 4 means we're looking for orders in the shipped state. Okay, so that's just a string. We've just created this query string. So now we create an object called record set, which is both used to query data from the database, and then also to then look at the results of that query. So we create a record set object using the new object command again, and again it's a COM object, component object model, and so we give the name of the COM class, ADO-DB record set, ADO again being active data objects. Then we call the open method on our record set, and again the parameters of a method are enclosed in parentheses. So the first parameter of the open method is the query string, which we just defined on line 15. That's the SQL command that we're going to execute. The second parameter is the connection object that we previously opened. So that was the object we created on line 5 and opened on line 6. Then these 2 are the variables we defined on lines 1 and 2, open static and lock optimistic. So it's just 3 and 3. And to see what those mean, we can look at the documentation for the open method here. We see that the parameters to the open method on an ADO record set are oh, actually, it's not the open method that we were interested in. It was the oh, it is the open method. Yeah. So we have the query. We have the active connection. Then we have a cursor type, a lock type, and optional options. So the cursor type is we're using a static cursor. So that means that we're going to get a set of records back, but any changes made after we've done our query are not visible to us. So the result, we get back a result that doesn't change underneath us. And then the lock type, we're using lock optimistic. So I don't know why you choose this particular value over other values. I sort of got that from an example, and I just looked up to see what these things meant. I'm not really a database expert, so, but anyway, this does work. So we call record set open, and now we've got back a set of records that matched our query. And now we want to iterate or loop over those records to actually get the information we are interested in. So for that, we're going to use a for loop. And and there are 2 methods and a property on record set that we're going to use here. The move first method. So the record set can be thought of as like a cursor that you advance through the sequence of results. So the move first method will advance the record set to the first record. The move next method will advance the cursor from whatever the current record is to the next record after it, or one past the last record if there are no more records. And then the EOF property is a Boolean property, which is true. So EOF stands for end of file. So it's true if we're past the last record. It's false if we're still within the record set. Okay. Now the for loop, a for loop in PowerShell, and is similar to in C or in C#. It has three. So we say for, we use the for keyword, and then inside parentheses we have three expressions separated by semicolons. The first expression is evaluated once when we first enter the loop, or before we enter the loop. The second expression is evaluated before every iteration of the loop, and it tells us, it's a Boolean expression that tells us whether to actually enter the current iteration or to fall out of the loop. So if true, we're going to loop as long as this condition is true. And if once this condition is false, we fall out of the loop. We go to the closing brace and to the next statement after the closing brace, like in line 26 here. And the third expression is evaluated after every iteration of the loop. So we have before the first iteration, and then a Boolean condition to evaluate before each iteration, and then we have after each iteration. Okay, so with record set here, in our example, before the first iteration of the loop, we call move next, so that we position the record cursor, if you will, on the first record. Then, before each iteration, we say, are we at the end? So if we're at the end, if we're past the last record, this will be true. So as long as it's not true, as long as we're not past the last record, then we're going to go ahead and loop. And we're going to go ahead and execute the loop body. Okay, so true means we're staying in the loop. False means we're falling out of the loop. Okay, so then we're going to process that record, which I'll get to in a second. And then after we finish processing one record, we call move next to advance to the next record. And then after we've done that, for the second iteration, we'll again evaluate this expression. And if we've just processed the last record and we're now outside, we're not past the last record, then EOF will be true. So not EOF will be false, and then we're going to fall out of the loop and go down to line 27 where we close the record set. Okay, so the net effect of all that is that this loop body, lines 20 through 24, are executed once for each record in that record set. And the record set is positioned on that record. So it has kind of a state that it has always a current position in the result set. Okay, so this code is then executed once for each record. So the first thing we do is we construct an object of type shift order, the class that we defined on line 8. So here is our type name. So we're saying new object, type name, shift order. So that's the class we defined in line 8. And we assign that new object to a variable, which we call order. Then on lines 21 through 23, we initialize the properties of our shift order object. So we set the order ID property to field 0, the value of field 0 from our record set. So, our record set has fields that correspond to the selected fields in our query. So here we selected these three, remember the table in the orders table had a whole bunch of fields, but we've just selected these three. So order ID is going to be field 0, customer ID is going to be field 1, and ship date is going to be field 2. So here we get field 0, which is the order ID. We get its value, and we assign it to the order ID property of our order object. And likewise for fields 1 and 2, we assign those to the customer ID and shipped date properties of our new object. And then we call write output with our order object because we want to include this object as one of the outputs of our function. And we don't, the write object is actually optional if we just say it like that, but we'll do the same thing. But I like making that explicit. So once we've run out of orders, we fall out of the loop, and then we've effectively written one shipped order object for each record in our results. And then we close our record set. That makes sure that any resources that are tied up from our database access are released. And here we call our get shipped orders method, and of course that method is going to return. Pardon me. It's going to return an array of shipped order objects, and so that's what the output of our script will be. And finally, we close the connection that we opened on line 6. Okay, so having explained all that, let's go ahead and run our script. I'm going to switch over to a PowerShell window here, And let's see, it was query orders1.ps1 was the name of our script. And we find that we get back 2 objects, and it's formatted them in this way. You know, we have an array of shipped order objects, and each of them has these 3 properties. And so it's given, PowerShell has automatically formatted that in a tabular format. If I wanted to, I could say format list instead of format table, and then we get it in a list format. So each object has an order ID, a customer ID, a shipped date, just as we expect, because that is how we define our class, is having those 3 properties: order ID, customer ID, and shipped date. And if we look back at our database, let's take a look at our actual results here. So order ID 12 is right there. And we see that indeed, or order ID 12 has status ID 4. So that's one of the ones we were interested in. And it has customer ID 7, which is what we expect. And it has the ship date we expect right here. The ship date column matches what we have in our output. So indeed, this is working the way we expect it to work. Okay, so that is our first query of a database from PowerShell. All right, let's take a look at a slightly more complicated query. So this is building on the previous script we just looked at. But in this case, we're going to combine the results from 2 different tables. So this is going to demonstrate how to do what's called an inner join in a database. So again, this code is all the same. We're opening a database connection. And here's our shipped order class, just like we had in our last script. The only difference is that instead of having a customer ID, I've included a customer name. And so our shipped orders function is now going to have to get the customer name instead of just the ID. Now the customer name is in the customers table. It's not part of the orders table. So this is why we have to use a query that combines 2 different tables using what's called a join. So this is getting into how relational databases work. As I explained before, one table can have a field that is a foreign key, meaning it is a reference to the primary key of another table. So the query string, again, is pretty much the same. We're doing select. We're specifying the fields we want: order ID, shipped date, and customer name. We're going to use customer name now instead of customer ID. But here's where it gets a little different. Instead of just saying from orders, we say from orders inner join customers. So we're taking 2 different tables and we're combining them together, joining them together as to create sort of one virtual table that is the combination of the 2. And how do we do that? Well, we have to specify what we're joining them on. This is sort of the relationship that is joining these tables together. So we're saying that the orders table's customer ID field that we relate. So how are the records in these tables related? They're related because a record in the orders table, if its customer ID field is the same as an order in the customers table's customer ID field, then we said that those 2 records belong together. So those 2 orders are joined together. And essentially we create kind of an Uber record that combines all the fields from both tables that have the same customer ID. And again, we're just as we did before with the where clause, we're only interested in the records where status ID is 4, meaning records that are in the shipped state. Let's go back and look at our table here. Oh, and again, these are the 3 fields we're interested in. Let's go back and actually look at the database. So I'm going to close these guys out here, and we'll instead look at the actual table definitions. So if I go to orders and right-click and go to design view, we can see that orders has an order ID and a customer ID. And of course, the shipped date. Those are kind of the fields we're interested in, and the status ID. And the customers table if we go to design view again, it has a customer ID and it has a customer name. So the customer ID is what is allowing us to create this relationship to link these records together across the two tables. And the customer name is the actual field that we want to pull out and include in our results. Okay, so the customer name is referenced here. This customer name is a reference to the customer name from the customers table. And then these two fields are pulling out columns from the orders table. So the combined table has all three of those things, the joined table, if you will. Okay, so that's that. So that's our query string. The record set is exactly what we did before. We open it using specifying the query, exactly the same for loop where we iterate over all the records in the record set. And then again, we create our shipped order object and we initialize the properties of that object to the fields 0, 1, and 2 of our record set, which again correspond to the three fields that we are selecting in our query: order ID, shipped date, and customer name. Okay, so once we've done all that, we should have our customers. Let's go ahead and run our script, and we'll say query orders 2. Oh, you know what? It's not going to work because I have the thing. The database is locked while I have it in design view. So I'll have to close out of that. All right. Let's run it again. And then we have, again, we have two results again, just like we did before. But instead of having the customer ID, we have the customer name. So before we had customer ID 7, for example, for the first result. If we look back at our database, we see the customer ID 7 is Tailwind Traders, and so that's this one here. Order ID 12 corresponds to order ID 12 has customer ID 7, and so that's Tailwind Traders. Order ID 28 had customer ID 1, and that's Edatum, if I'm pronouncing that correct, Corporation, which is what we get here. Okay, so that is a little bit more complicated query where we've done a join in order to be able to merge the results of two different tables into one kind of virtual table, one record set. Okay, so we figured out how to get shipped orders from our database by combining these two tables, the orders table and the customers table, in order to get a shipped order object that has an order ID, a shipped date, and a customer name. Now, in our database, the order ID doesn't have all the details of the order. It doesn't have like the actual inventory items or the actual what the customer purchased. For that, we need to go to the order details table. So let's say we want to create a billing statement or something that includes, for each customer for each order rather that is in the shipped state, we want to be able to send a customer a bill that includes an itemized list of all the things in that order. Well, let's again look at our database, and let's say order ID 1 or whatever. Oh, sorry, that's the order details table. Let's go to the orders table. So for order ID 1, we have the information about the general information about our order, but it doesn't include what items are part of that order. That is in the order details table. So we have the order ID 1, and then we have the order details table has an order detail ID that's unique for each order detail, but then it also has an order ID, and there's kind of a one-to-many relationship here. We see that there's multiple order details that have the same order ID. So, for example, order ID 1 has 3 order details, right? So there's 3 items that are part of that order. And order ID 5 has 2 order detail records. So there's 2 different line items, if you will. Each of these order details is like a line item as part of the order. And each of those line items has a quantity, a unit price, and so on. All right, so in order to produce an itemized bill or something, we need to query this order details table. So let's go back to our script. And here again, we've we've opened the database, created a connection to the database. We have the function we wrote in our last script to get sort of summary information for each order, for each order that's in the shipped state. It includes the order ID, the ship date, and the customer name. And then we have another step we need to do in order to query what all the items in that order are. So here I've defined an order item class, and we have a function very similar to get shipped orders that will query to get the order details for a particular for a given order. And again, we have to use a join because we're interested in the name of the product. If we go to the order details table, we'll see that there is a product ID field. So this product ID is a reference to a record in the products table. So the products table then contains all the different kind of products that we sell to our grocery store customers. And so each of these product records has a product ID, and so each of the order details records, which is like a line item in an order, references an item in the products table. So if we want to get back in our results, we want to get a quantity, a unit price, and a product name. We need to get that product name out of the products table. So it's very similar to the one we did last time. We have a query string, which is a SQL select statement, and we're going to get 3 fields in our result. We're going to get a quantity, we're going to get order details.unit price, and I'll explain why we included order details dot in here. But this is referring to the unit price field of the order details table. And we're getting the product name. And we're getting them from is not just one table, but again, a joined table. So we're taking the order details table and we're doing an inner join with the products table so that we can get the product's name. And we're joining them on the product ID. So for each of these order details records, we want to combine it with the corresponding product record that has the same product ID. So we say on order details product ID equals products product ID. So records from both tables that have the same product ID will be merged together, and that will be what our result set looks like. And again, we're going to filter it to only include records where the order ID is equal to the ID that we're asking for. Because again, we've got a particular order. We want to find all the line items that belong to that order. So that was passed as a parameter to our get order items function. Okay, so that is our query string. And I said I would mention why this has order details dot unit price. That's just to resolve an ambiguity. And the reason there is because both the order details table here, it has a unit price column, but the products table also has a unit price column. So in effect, when we merge these two tables, there are really 2 unit price records. And in order to avoid ambiguity, I said that I want the one from order details. Why does it matter which one we use? It matters because what if the price of that product changed after that order was processed? Well, the price we want is the one at the time that that order was created, so that would be reflected in the order details table. Okay, so we have get order items. So we have our query that we just talked about. Again, we create a record set object. We open the record set object, specifying our query to get the results. And then we walk through it using our for loop, just as we've done before. And then within each iteration of the for loop, we create an object called order of type order item. And we initialize the 3 properties of our order item to fields 0, 1, and 2 of our record set. And those fields again correspond their position in position to the 3 selected fields from our query results. And finally, we write output the order in order so that the return value or the results of this function are an array of order objects, 1 for each record that matched our result. And then when we're done, we close the record set. So exactly the same as our previous function, just a different query and a different type of object that we return. So here is where we put it all together. So we call get shipped orders. So this is going to return an order, a shipped order object. Remember this class we defined at the top here. It's going to return a shipped order for object for each order that's in the shipped state. Oops, hold on. I jumped around without meaning to. Okay, so we call get shipped orders. And then for each of those order objects, we pipe that to the for each object commandlet. So for each of those order objects, we're going to execute this code, this script block. So for each of those orders, we're going to write order for customer name. So we output the customer name. So we're doing string interpolation here to insert the customer name into this string. And because this is not just a single variable, I had to wrap it in $ parentheses so that basically this whole expression inside the $ parentheses gets evaluated and inserted in place of the string. Then we say order for so-and-so, comma, shipped, and then again we have the $ parentheses, so the expression inside there gets inserted into the string. So that's the shipped date from the current order. And remember, $_ is the pipeline variable, so that's always, when we use for each object, this magic variable $_ is whatever the current object is that we're processing for this iteration of the for each object command. Okay, so we write a summary line, order for so-and-so, shipped on such and such. Then we initialize a variable to 0 because that's going to be where we total up the cost of each item, of each line item. Then we call our other function. We have an order ID that's part of the order object we got back. And now we call our new function get order items, and we pass the order ID parameter. So this order ID here, line 56, corresponds to the order ID parameter that we've defined as a parameter to the function on line 37. So order ID, the value we're passing for that parameter is the order ID from the orders table, right? So this is the primary key from the orders table that identifies the order. And then, of course, within this function, we are querying for all of the order details that have that order ID, right? And then for each order item object that we get back, remember this is what we return from the get order items method. For each order item object we get back, we say the price for this particular, or the cost of this particular line item is going to be the quantity times the unit price. And we output this to string. We say product name is equal to quantity, or product name colon quantity at unit price equals item price. And then we update the total by adding it to the item price. And at the very end, we'll just write out the total is such and such. Okay, and then when we're all done, we close the connection. So let's go back to our PowerShell prompt and query orders 2. Oh, whoops, we already did that one. Query orders 3. We're on 3 now. Okay, and this is putting it all together. We have order for a Datum Corporation, and now we've essentially this is coming from the shipped orders object, the first query we did, and for that, within that we then query for the order items. It's coming from the order details table joined with the products table, and we get almonds, 11 almonds at $10 per almond is $110, and then the total is $110. And this one we have an order that has 4 items, syrup, clam chowder, etc. Maybe it would help to actually look at the database here. So we have order for, let's see if we query orders 2 on that list. Okay, so the Tailwind Traders one has order ID 12, right? So we got order ID 12, and we called our second method with 12. If we go back to our database and we look for order details with order ID 12, we see that we have 3 records. And those 3 records have product IDs 27, 15, and 2. Right, so the second column is the order ID. So we have 3 records with that order ID, and then those have refer to product IDs 27, 15, and 2. And if we go to our products table, we see that product 27 is dried plums, product 15 is clam chowder, and product 2 is syrup. And if we go back to our output from our script, we indeed have syrup, dried plums, and clam chowder. So that's how we are able to combine all those results. Okay, so we've looked at how to query a single table from our database. We've looked at how to join two tables together two related tables together using the inner join SQL statement. And we've also done sort of nested queries where we queried orders, and then we separately queried the order ID or the order details table in order to get the particular line items for each order. Now let's say we want to produce output that's a little bit more interesting or useful than the console output we produced here. So the rest of the last two examples are going to show we're just taking the same output we produced here, but outputting them in a different format. So the first one I want to show you is just writing a simple XML file for each of these orders. So the first part of this script is exactly the same as before. We have our shipped order class. We have our function to get the shipped orders. We have our order item class. We have our function to get the order items for a given order ID. That is exactly the same as before. The new part is we're going to take an order object and we're going to write it to an XML file. So XML, Extensible Markup Language, is a kind of a text-based structured language that uses tags and so on to represent data hierarchically. I had another video I did on reading and writing XML from PowerShell. This is really, and that talks about that specifically. This video I'm just going to kind of build on that knowledge. If I go too quickly here, you can refer back to that video for a more detailed explanation. But here I create the name of the file I'm going to write, and I just call it, I'm going to put it in the current directory, or the same directory rather that the script lives. So I use the join path command to combine the ps script root directory, the directory containing the script, with the file name, order hyphen, and then the order ID from our object, and then xml.xml. So I write that name of the file to the host. So this is just outputting to the console. Then I'm going to create an XML writer settings object. This just allows me to customize some behavior of the XML writer. And I'm just saying to omit the XML declaration. You can either put that in or not. It's up to you. And also I want to indent. So I want the XML to be formatted so it's human readable. And putting in some white space and indentation so that we can look at the results and make sense of it more easily. Finally, I create an XML writer object. So for that, instead of using new object like I did here with the XML writer settings, the XML writer class has a static create method. So we invoke that method by including the class name in square brackets, and then colon, and then this static method called create. And then like any method call, we have to include the parameters in parentheses. So the parameters here are the file name and then the XML writer settings object we created up above. All right, once I've created the XML writer object, then I can begin writing the contents. So an XML file consists of elements that are organized in a tree. So it's hierarchical in nature. So for every element, we have to write a start element, and then we write an end element. So we start with the order element. We're going to create the top level element we're just going to call order, because this file contains information about a particular order. And then for that order element, we just write some attributes. We're giving the order an ID, which is the order ID property of our order object. The customer is the customer attribute of the element is going to be the customer name property of our object, and the attribute, the shipped date attribute is going to be the shipped date property of our object. So that's all straightforward enough. Then we, again, like we did with our text output, we're just going to keep a running total of the cost of all the line items. And then we loop over each of the items in that associated with that order. So again, we have our order ID. We call our getOrderItems method to query all of the order details records that have that order ID. And of course, that's actually doing a join of order details and the products tables. But we get back the what was that? We get back an order item class because that's what that function returns. So for each of those order item classes, we execute this loop body or this code block. And so we calculate the item price, which is again, this is the pipeline variable, is the particular order item. So we take the quantity and the unit price for that order item, and that is our total price for that line item. Then we write another begin an XML element called item. We write all these attributes: the product, the quantity, the unit price, and the cost being the product of quantity and unit price. And then we write the end element. So every time we call write start element, we have to have a corresponding call to write end element. And then we update our running total. Then when we've run out of orders, run out of order items, we have no more line items. Then we write one last item, we just call it total. And it has a cost attribute, which is the sum total of all the items. And then we end our total element. And finally, we end our top level order element, and then we close our writer. So that's how we write our XML. So here's where where we actually invoke it. So we call get shipped orders, which gives back our shipped order object for each order that's in the shipped state. And then we for each of those orders, we invoke our write order function that we just looked at to write the order details. So let's go ahead and run this one. This is query order 4. So let's go ahead and run that. Query order 4. Oops. Query orders 4. There we go. Left out the S. So run that. And it says writing order 28.xml and order 12.xml. So those are, again, the file names were included the order ID. So we have order 28 and order 12. And now if we go back to our, we see that now we have a order 12 and an order 28 XML file. And this is what the XML looks like. So we have our order element, which is the root element, and it has these attributes, just like that correspond to the orders we've specified. And then for each of the items, we've written an item element for each of the line items that has a product, quantity, unit price, and cost being the product of quantity and unit price. And then we have our total element. Okay, so this is sort of an XML representation, very similar to what we wrote to the console in our previous example. And you might do that. You might then use that XML as input to some other process. You can do all kinds of things with XML. So being able to get data out of a database into XML could be an intermediate step in some other kind of processing you want to do. This last example is very similar to the previous one. We're going to write XML, but in this case it's a special case of XML. We're going to write HTML files for each order. So HTML is the language of the web. So whenever you view a web page, you're viewing an HTML file. It stands for Hypertext Markup Language. And HTML is actually just an XML schema. Not in every case. Not every HTML file is a valid XML file because HTML actually predates XML historically. But if you write an XML file that conforms to the schema for HTML, then you have a valid HTML file. And when I say schema, what I mean there is that XML being an extensible markup language. That means you can define whatever tags you want. Like we just made up what tags we wanted to include in our previous example. We said, okay, we have an order tag, and the order tag contains item tags and so on. Well, HTML has very definite tags that have very definite meanings that represent the appearance of a document. So we're going to write an HTML file, but using the XML writer that we did just like we did before. So so here we have our write order function, similar to one we did last time. But now we're going to write the XML we write is going to be HTML. Now, one thing is that the XML we produced in our last example did not put anything into namespaces, but XML elements can be in namespaces. And for HTML, excuse me, for HTML, the namespace is right here. So this is basically saying that the tags in the HTML in the markup, they don't just have a name; they also belong in a namespace. Just like in the .NET framework, class names can be grouped into namespaces. Well, tags in XML can be grouped into namespaces. So the full name of the element is really its local name plus its namespace URI. And the namespace URI for HTML elements is defined to be this. Okay, so we've created our file name just like we did before. This time we're giving it the extension HTML instead of XML. We just output to the console that we're going to write that file. Create our XML writer settings, same as before. Create our XML writer, same as before. And then we write our start tag for the HTML document, which always has to be HTML. So HTML has a certain structure. The top level element is always called HTML. And then inside the HTML element, we have a head element and a body element. And within each of those, we have various stuff. So here's beginning the head element at line 70. And from line 70 up to line 86, we're writing the head section of the document. So the head element really just contains sort of metadata for the document as opposed to the content of the page. So in our head element, we include a title. We say billing invoice for customer name. So this is just initializing a string, which is what our title is going to be. We write a title element. We begin our title element. Oh, and by the way, so each time we call write start element, you notice we're using an overload of this method that takes both the local name and the namespace URI, which is the variable we created up here. So that's how we are. That's how we're getting the namespace in there. Okay, so we write our title element, or we begin the title element. Then inside the body of the title element, we just write the title string itself. So that's coming between the start tag and the end tag. And then we write the end tag for the element. And then just to make the formatting a little nicer, I included a style sheet. And to make it self-contained, I just include the style sheet directly within the body of the document. So I write a start element called style, and then I get the style sheet is in the cascading style sheet CSS. Cascading style sheets kind of language. So here's the style sheet I created. I can go into that a little bit more detail if you want. Anyway, just get the content of that as a string, and we write that as part of our after the start tag, and then we write the end tag. So in between the style start tag and the style end tag, we have this markup that says that the formatting attributes of different tags. So what this is doing here is saying paragraph, P tag is for paragraph, H1 and H2 are, level 1 and level 2 headings. TH and TD are table heading and table data, so those are different cells in a table. So separating these with comma means that any of those have these properties. So we assign this font to any of those. Then for P, for paragraph, we give it a font size. We give it the margins that we want on the top and bottom. Likewise for heading 1, heading 2. For the table, we give it some, we take out its margins, or its left margin. We add some margin above. We say that we want empty cells to be visible. And then for either table heading or table data, we align them to the left. We give it a font size. We give it some padding. And then for table headings, we specify we want a border below. And for the this means that a table data element that is contained within a tr.total, so that means table row that has the total class. So there's a class attribute. So if you have a table row that has the class attribute equals total, or class equals total, and then any TD within that table row will be bold and have a 1 pixel thick solid black border above it. Okay, that was probably, when we actually look at the results of this in a browser, we'll see what that means. So let's take a look at our script again. So we've included our style sheet, and then we're done with the head section. Then we begin the body of the document, which has the actual text and content. We write a heading 1 element. So the title attribute we wrote in the heading is just like what appears in the title bar or the tab of a browser. It's not actually, it's just sort of the part of the metadata. Here we've actually written a heading that is part of the body of the document. So we give it an H1 tag and we include the title. Here we have a paragraph. So we say, we begin a P element, which stands for paragraph. We say payment is due for the following order. And another paragraph, order ID, colon, and then the order ID. And another paragraph, ship date. And then we write an H2 element, so level 2 heading. And so we have a start and an end tag, and in between we write the string order details. And then we begin a table, so we have a table start tag, cell spacing and cell padding. There's by default, there's some spacing that gets added between and within cells, and I just take those out because I want to control the spacing using the CSS. And then we write a header row. So we have TR stands for table row. So so we have a TR start element, and then we have the end of the header of the end of the row. And then within the table row we have a TH start and end element with product. So this is the heading of the product column, the heading of the quantity column, the heading of the unit price column, and the heading of the cost column. So these are it's a table row, and then the heading cells from left to right are product, quantity, unit price, and cost. And each of those has a start element, end element, and a string in between. And then we have the end of the row. And again, just like we did before with the simpler XML, we start a running total, and then for each order item, we compute the item price, the product of quantity and unit price, and then we write another table row, and for each of those things we write a cell, a TD element for table data. So we have a TD element start tag and end tag with the product name in between, a TD start and end tag with the quantity in between, a TD element with the unit price in between, and a TD element with the item price, that is the product of quantity and unit price in between. And then we end the table row again. And again, we update the running total. Then at the very end of the table, or after all the individual items, we have one final row for the total. So we just write total, so here we write a TR to start the table row again, and we give this TR the class a class attribute, calling it total, and that is again so that our CSS can give different formatting to the table data elements within that row. And then we begin a TD element, we call it total. Then we have a couple of blank TD elements because just so that the next two columns are empty. And in the last column, we write the actual total cost for this invoice. And then we end the table row. And then finally, after ending the last table row, we end the table element. And after ending the table, we end the body element, and then we've closed our writer. Okay, so quite a bit more to write there to produce the HTML than there was to produce the XML. But let's go ahead and run our script. Query orders 5. And we see we've written order 28.html and order 12.html. And if we go to if we look at the markup, so here's order 12 XML. You can see it's nice and compact because it's just a compact way of representing the raw data. But in the HTML is giving us a formatted representation of that data. So we see we have our XML namespace, which is what identifies this as HTML. We have the head, the head section. Pardon me, I have a drink of water. With our title and our CSS. And then we have our body section. That includes our heading, a couple of paragraphs, a second level heading, and here's our table. Here's the header row that we wrote. And then here are the rows for each of the order items. And then here's the totals row with again a couple of blank table data elements so that this is our last column. And then we end everything out, and that's our HTML. So how does it look when we open this up? We'll say order12.html, and here we are. So now, of course, you can put a lot more work into making a proper billing invoice. This is just to illustrate the concept. But you can see how you can produce something that is formatted nicely. You could then use this to print it out and mail it off to a customer to request payment or something. So that is, in summary, we have looked at how to connect to a database using PowerShell, how to do simple table queries, how to do joins so we can combine information from related tables, how to do nested queries so we can do one query that gives us a per order information, and then a nested query within like a loop to get the individual line items for a given order. And then finally, how to take those results that we get from the database and output them to XML or to HTML, which is just kind of a special case of XML. I hope that you found that helpful, and PowerShell is kind of a very easy and convenient way to interact with databases. So yeah, hopefully that will be useful to you. Thank you for watching. Bye.